Hello, I'm Dr. Jennifer Ripley, and I'm going to be giving a mini lecture on the concept of variability and the measurement of variance and standard deviation. This is created for the statistics class at Regent University's Doctor of Psychology program. And the concepts are basic and they're part of the first unit of review of basic concepts in statistics that all students really should know prior to coming to Regent University, but we're going to do a little review of it. So there are actually many different measures of variability, and the three major ones, particularly found in the field of psychology, is social sciences, are range, standard deviation, and variance. The important thing to understand about them is that range is helpful just so that you can understand, how far your bell curve is running, essentially. When you think about the bell curve concept or, working underneath that bell curve. But standard deviation is the most common one presented in articles and book chapters, that sort of thing, or presentations at conferences. You'll primarily hear people present their standard deviation. It's kind of the average amount of difference or deviation that each score has from the mean. So it gives you a good sense about how far from the mean something is going, particularly if you understand the measure fairly well. And then variance is the raw score, so it's not standardized. It doesn't have the square root. So variance is broader, but variance is the raw score that is used behind the scenes in many statistics calculations. That a measure of variance will actually be a part of the actual formula for statistics. So understanding these three concepts will kind of get you set in terms of descriptive statistics in psychology. Of course, most of the time people report the average or the mean and the standard deviation, and that kind of gets you a sense of what the data looks like and if it's normal for that measure or not. Computing standard deviation as the most frequent computation, and it's a pretty simple concept. One of the things to think about is what you have going on here in terms of what's underneath this. First of all, the square root that's going on, that is the standardization that's happening that helps everything to look a little more similar no matter what kind of scaling the measure is using. It's a little more anyway. Right here, you're going to see the score itself minus the mean score for the sample, and so the difference, and it's going to sum up, right, all of those, right? So every score has a certain distance from the mean, and if you were an undergrad stats, you had to probably do this by hand and, small amounts of torture, but you have that, and then it's squared as a way to standardize that, and then over, underneath that, and the denominator is the number of participants either in the group or in the sample, depending on what kind of statistic you're running, what you're doing. But they also reduce by 1 as a kind of a conservative estimate. So all of these things, I want to make sure you understand what they mean, what they're about. But in general, you want to think in terms of, this is like how far from the mean every score is, and then over the number of participants, kind of the average then, right, of it. And that's squared and then square rooted so that it's all standardized. So why do they do the n-1 in the denominator? I want you to remember that standard deviation is an estimate of the population standard deviation, right? So this is trying to estimate the actual population, not the sample that you have in front of you. So to make it an unbiased estimate for the sample, you have to subtract a 1 from it to try to make it less biased. Otherwise, this artificially inflates it. Actually, the n-1 that you do does inflate it a little bit, making it bigger, which actually makes the denominator smaller. So in the long run, what you're ending up with is standard deviations that are slightly smaller than they would be, because the idea is that the population is actually probably a little more conservative than the sample. Samples tend to broaden out. So that's all theoretical, has to do with, central kinds of things, or more probable than extreme things. But if you can kind of understand the concept of that this is about population and standard deviation is an estimate of the population standard deviation, then you're in good shape. It is computed in standard deviation as the average distance from the mean for your sample. The larger the standard deviation, the more spread out the values are in your variable. So the more platykurtic your bell curve is going to be. If you have a very large standard deviation, you have a really flat curve. If you have a very small standard deviation, you have a very tall curve, right? Like it's leaping, it's leptokurtic. And then in the middle gets you a nice mesokurtic kind of spread, which is what you want. Like the mean, the standard deviation is sensitive to extremes and outliers, and so you always want to be hunting and making sure you get rid of your extremes or outliers prior to running your standard deviation and mean. If you have something that has a standard deviation of 0, then there's absolutely no variability in the scores. Everybody's getting the identical score, or in other words, you have a constant, all right? So everybody has the same score. On something, there's no variability. Without variability, it's called a constant. Variance is the other measure, and it's how much a variable varies. It's very nice that they chose that term. It makes it easy, and it's actually just the standard deviation squared. So it's essentially the measurement without being washed in the laundry. So you get the same kind of concept yet again with this, where you have the score for each person or mouse or whatever you're measuring, minus, and you subtract out what the mean score was for the sample, and you square it, and then you put it over n minus 1, still n minus 1. So finally, I just want to show you what the results would look like in SPSS once you run it, which is a fairly simple thing to run. So I'm not going to show that here. You can find it on the internet as well as do it in class lab. But you'll get something that looks like this. If you ask it, give me standard deviation, here's your standard deviation. What this is saying in front of you, what you're seeing here, is that you've got a sample of 30, right? No missing people. And then the standard deviation for this sample is 0.70, rounded off. The variance is 0.494, so 0.49 rounded off, and you'll notice that that's squares of each other. And then the range is 2.6, meaning the distance from the highest to the lowest is 2.6. That's a very small range, right? Like it's a very small range. That's a very small standard deviation for most things, and a very small variance. So it's less than 1 point on the standard deviation there. So definitely not the IQ test for this. So hopefully that helps you just to understand what you're looking at when you read the results. Thank you very much.